Hello, this is our lesson on motions and forces today. So today we're going to talk about different motions and forces. So we should have done our readings last night, and you should have gotten a little bit of background information about that. So, where are we going with this? What do I want you to learn from our lesson today? So, you're going to be able to apply the principles of Newton's laws of motion, investigate how force, mass, acceleration, and velocity interact, and eventually we'll be to the point where we can create and perform our own experiment demonstrating Newton's second law of motion. So, what does all this mean? What all's this going? We will figure this out. So I want you to open your notebook to a new page and I want you to put today's date. So today is December 1st. So put 12/1 and then put motion and forces lecture 1 at the top, please. All right, so now that you've done that, we're going to talk about Newton's first law of motion. So I want you to put your pencils down. We are not writing anything down yet. So I'm just going to read off what Newton's first law of motion is, and then we'll come back and talk about it. An object at rest will remain at rest unless a net force acts on it. An object in motion will remain in motion unless a net force acts on it. So what does this mean? Well, first we got to review some vocab. A force is a push or a pull on an object. So you see force is highlighted in blue. This means it's a good vocab word that I think you should have written down in your notebook. So if you want to go ahead and pick up your pencils, that now would be a great time to. So can anyone think of any examples of forces? Yes, a force could be you pushing a ball. That's a good example of a force. Can anyone else tell me what a force is? Awesome. Yes, a force is you pushing the cart at the grocery store. That's an amazing example of a force. All of these are different forces that we see in our everyday lives. So when you open and close your locker, you pulling it open is a force, you shutting it closed is a force. All of these things are forces. So if we go back to our definition of Newton's first law of motion, an object will remain at rest. So my object will be my phone. It is at rest unless a force acts on it. So let's act a force on it. Let's push my phone. And now it fell over to this side of my room. And an object will remain in motion unless a net force acts on it. We're going to pretend my hand isn't here and my phone is just going and going and going and going until my other hand, it's another force acting on it, which is stopping my phone. So the soccer ball, whenever you kick a soccer ball, does it stay in motion forever? No, I wonder why that is. There are many forces, including forces that make them stop. We will talk about these later, but just remember that in the back of your head, that a force is any push or pull. We will talk about this more in our lecture tomorrow. So now that we've talked about that, we can talk about Newton's second law of motion. So we have a force. We just talked about a force. Can anyone tell me what a force is? Thank you. We have a mass and we have an acceleration. Oh my gosh, new vocab alert again. So I want us to write down mass, acceleration, and velocity in our notebooks. So mass is the amount of matter in an object. We talked about this back in our matter unit. It is really important that we are remembering our vocab from our prior units because we are going to use it again. Acceleration, the rate of change of velocity. We have also talked about this in our prior unit about acceleration and velocity. We also have talked about this unit vocab. So it's really important, guys, that we are making sure that we keep our vocabs sheets and that we keep them nice and organized so we can find them later. But if you want to write them down again, I'm going to leave this up here for a second. So going back, we see that force, mass, acceleration, and we see a little equation down there that says force equals mass times acceleration. So our mass is measured in what? What is mass measured in normally? What is our standard unit of mass? Think of it in your head. All right, I'm going to call one person. Boop. Yes, it's in kilograms. Kilograms. And acceleration is measured in, who can tell me what acceleration is measured in? Use your past notes if you need to. Yep, meters per second squared. So that's m/s squared. All right, now force. We talked about what a force is, but we never talked about what it's measured in. A force is measured in a Newton. Newton. Thank you for my short little lecture.